Before I get started with today's lesson, I want to first refresh you on your sine and cosine parent functions. So recall that the sine parent function starts at 0, 0, okay, and from there we go up and then down and start your cycle back over again. The cosine parent function starts at 0, 1, goes down and then back up, and then of course you start over again. So a couple of things I want to point out is notice the sine graph starts at the midline, while the cosine graph starts at this local max here. If we were to reflect this cosine graph, it would start at the local min and proceed up. Okay, so just a couple of key attributes about the sine and cosine graph. We will use these today. So for today, we're looking at notes R-1 writing cosine equations. Tomorrow we'll be looking at writing sine equations. So cosine equations that have been transformed, of course, have this general form where A is the amplitude, D is the midline. Remember, that's your vertical translation, either up or down. All right. For each of the following, we will find the cosine equation of the graph. Well, if you think about it, these cosine graphs and sine graphs are kind of similar to the step function graphs because there are many equations we can write that will all represent the same graph. Okay, so we're just picking one out of the many that could be. So for today, so I see which portion of the graph you're working with, I need you to darken that portion of the graph your equation will represent. So you have a choice, okay? You have a choice for cosine to either start at one local max or one local min, okay, to the next local max or min. Now let me be very clear. If you start at a local max, you've got to finish at a local max. If you start at a local min, you've got to finish at a local min. You can't just go from a max to a min because that would not complete one full cycle. So if you start at a max, you finish at a max. If you start at a min, you will finish at a min. So as you can see, on number 1, I've already darkened the portion of the graph I wish to use. I chose this portion only because, again, refresh your cosine graph. The parent function starts up top, starts at a max, finishes at a max. We could start at the min, but of course that would be a reflection of the graph. And for now, I just don't want to deal with that, but we will later. I promise you that. So we've got local max to local max. This is the portion of the graph I'll be dealing with. And again, there are many equations that represent the same graph. We're just choosing one of the many. Okay, so our steps. Draw the midline. We can see from this graph that our midline would be right here at y equals 1 because, as you know, it's our midline. As you know, if you count from the midline to either a local min or a local max, the distance will be the same. Our distance, our vertical distance from the midline to this local min is 3. Our vertical distance from the midline to this local max is also 3. So I've found my midline, I've drawn it in. So as we just talked about, we pretty much found A. So our A for this graph would be 3. We counted 3 here, we counted 3 here. So our A will be 3. Our D, because our midline is at y equals 1, our D would be 1. Okay, to find B, we have to go back and kind of think about some things that we've done before. So B, remember, our period comes from 2 pi times 1 over B. So 2 pi times 1 over B can be rewritten as 2 pi over B. So 2 pi over B equals our period. You can get the period by looking at the graph. So let's use this here. Let me kind of come up here to have enough space. So 2 pi over B, which we don't know what B is, equals our period. Our period, one full cycle, goes from pi to 5 pi. So what's the horizontal distance? It's 1 pi, 2 pi, 3 pi, 4 pi. So 2 pi over B equals our period. Our period is 4 pi. So as you might imagine, you can put this 4 pi over 1 and cross multiply. So 2 pi equals B times 4 pi, cross multiply, 2 pi equals 4 pi B. Solve for B. Well, divide by 4 pi, divide by 4 pi. Of course, the pi is simplified out. 2 over 4 equals 1/2. So 1/2 equals b. Okay, we have found b. Now we need to find c. C comes from bx minus c equals 0. Again, think about the cosine parent function. We want that x value to be at 0. The y value is 1, but the x value is 0. So set bx minus c equal to 0 and solve for c. So b comes from the b that we just found. So 1/2 times x, this will be our leftmost coordinate here in my darkened portion. What's my x value here? It's pi minus c equals 0. So basically pi over 2 minus c equals 0. We'll move over that c and you get pi over 2 equals c. So c is pi over 2. So now I can go ahead and write my equation. So I would have y equals a3 cosine of 1/2, our b, x plus minus pi over 2. Of course, opposite of intuition. This is plus, so we need to make it minus. Remember, our formula is minus. Okay, and then plus 1. So again, this is just this is one of many of the equations I could have written for this graph. That's why we darken it to show which portion we're talking about. Okay, so let's do one more example, number 2. So on this example, I'm going to darken the portion of the graph I'm going to choose because the way the graph is kind of designed here, I wouldn't have a full cycle if I started at the local max, so unfortunately I've got to start at the local min. You all know what that means, so I'm darkening this portion of the graph. First, I'll draw my midline. Your midline, you can tell, would be here, because again, if you count to that vertically, to that local min, that'd be 2 units. If you count to that local max, that'd be 2 units. That already tells me my A. So there's our midline. Midline. There's my A. Okay, but big key here. If on this cosine graph, you are going from local min to next local min, remember, lead negative. We talked about this. So remember that the only way you'd be going from a local min to the next local min is if you reflect it over the x, so that means you need your lead negative here. So instead of 2, it'll be -2. So then D, of course, is +1 because our midline is at y equals 1. Talk about B again. So remember, B comes from 2 pi over B equals the period. What's our period here? 1 whole cycle. What's our horizontal distance? So we're counting by pi over 2 every single time. So this is pi over 2. This is 2 pi over 2. This is 3 pi over 2 units. 4 pi over 2 units. So 2 pi. So put this 2 pi over 1 and cross multiply. 2 pi equals 2 pi b. So then divide by 2 pi, divide by 2 pi. And of course, you're going to get 1. So b equals 1. C comes from bx minus c equals 0. So b is 1. 1 times x, our leftmost x value here is negative pi over 2. Bx minus c equals 0. Again, you can move this c over. 1 times negative pi over 2 would be negative pi over 2 equals c. So c equals negative pi over 2. All right, so now look at our equation would be y equals -2 cosine, our b value is 1, no reason to really put it, x plus pi over 2, opposite, and then plus 1.